Welcome to the shop. In today's video, I'm going to be making a bending fixture for bending the wood pieces on my latest glass, wood, and metal sculpture. I'll be using the Bridgeport 2-axis CNC and making some aluminum parts. So let's get going. I've got my pieces pre-cut. I cut them on the table saw, and I figured that wasn't too horribly interesting and probably not worth taking the camera over to the table saw, but the pieces are roughly cut to size, a little bit oversized, and I put a little, cut the end off the corner of this guy, which is going to be the base plate, so I know where 0 is. On the other pieces, I may just remember where 0 is. I may go ahead and take a Sharpie and just put a mark, just so I remember where 0 is. I'm using the Bridgeport 2-axis CNC machine for this job, and when the Bridgeport is powered on, it doesn't have any method of homing to find where 0 is, and so I have to tell the machine where 0 is using an indicator. I'm using a Heimer indicator. This is an indicator that measures in 3 axes. Using the power drawbar to very quickly get it into place. Checking the knee to make sure it's about in the right place. And the Heimer indicator, it's calibrated. It has a little ball on the end, and then the indicator is calibrated. So when you get to 0 on the indicator, it means that the center line of the machine is precisely over the surface that you're measuring against. So it basically has the built-in radius of that ball built into the indicator. So now I go over to the screen and set X for 0. I'm using Mach 3 software with a custom screen that I made myself, even has my logo on it. Mach 3 works well enough. And there I've zeroed the y-axis. Then, just for a little kind of extra sanity check, go ahead and start up the servos and just type in tell it to go to 0 and just make sure that I haven't made some kind of stupid mistake that's going to end up biting me later. So the first step is going to be to take the first piece, put it in the vise, on parallels. This point is now defined as my reference 0, and in my toolpath software, I set that point on the part as reference 0. So I'm going to start off. This is going to be the actual part of the clamp that the wood touches. I'm going to start off here drilling some holes and go over one of the nice things about the Mach 3 software is that it runs on a Windows computer and it's on the network, so I can just bring up the file selector and go get the toolpath. I'm just checking here to make sure that the toolpath looks sane. I have a preview of what's going on the screen. It also tells me the tool that I'm using, and in this case it's somewhat unimportant because the program here is super simple. It's just 2 holes. And you might wonder, well, why did I go to all that trouble of making toolpath on a cam system just to drill 2 holes? Well, it helps me avoid making mistakes. If every step of the process I start from a master drawing in a CAD system, derive all of the other parts from the master, and then everything, no matter how simple, even just 2 holes, is all done in toolpath, it's all done in CAM, helps to avoid making mistakes. I don't use a drill chuck very often. In fact, I almost never use a drill chuck. I always use collets for everything. I've got a fairly extensive selection of collets, from 1/16 up to 1 inch in 32nd of an inch increments, so I can hold pretty much any size drill. I use the short drills, the stubby drills, because in most cases, for most work, I don't have to center drill or spot or do anything to keep them on target. They're short enough, and most of the material that I run is aluminum, and so I pretty much always get an accurate hole, or at least accurate enough. If I'm really doing like super precise work, then I'll do it the full deal with a center drill, spotting drill, pilot drill, reamer, whatever. But for most things, for most of the time, I just grab a collet, stick in my stubby drill, go over, and the power drawbar makes it fast. I think it's even faster than using a drill chuck. So let's go ahead and start the program. Get this guy out of the way. This guy is kind of an annoying thing on a CNC machine. Crank up the speed. Using a mist coolant system, peck drilling. And let me go get my deburring tool. And we'll go ahead and put this one over here. The next piece that I'm going to be making is the clamp that goes over the top of the curved section of the fixture. And its first operation is also very simple. Just has 3 holes, but I do have a tool path for it. Just sanity checking to make sure it looks reasonable. Okay. I made a little control panel with the cycle start button and the e-stop very conveniently placed. Kind of helps things a little bit. I like organizing my workspace where I have all of my milling cutters, all of my drills, taps, collets, cutting tools. Everything is pretty easily available within arm's reach. There's a few things that I've got to go looking for, but in most cases, everything I need to do the work is right here. Now, this is the base that the fixture will be constructed from, and it also is going to act as a tooling plate for machining some of the second operations on those other pieces. Checking, looks reasonable. I've got my tap drills in a block, which you may not be able to see in the video there, but I've got a labeled block with all of the tap drills, clearance drills, and taps for various different size screw threads. So I don't need to either remember the size or look it up on a chart. It's all there. So now, I'm going to be power tapping and let me go get my tapping fluid. I use Tap Magic for aluminum. It really works really well. So get the speed turned down a little. The three-phase motor on the Bridgeport is controlled by a VFD, and one of the things about a VFD, the VFD has to control the motor directly. You can't use a VFD with the typical kind of little rotary switch on a Bridgeport. So I made up a control box with remote control buttons, start, stop, and reverse direction. And reversing direction comes in real handy when power tapping. So now I'm going to load up the end mill. I'm using a 3-flute solid carbide from Lakeshore Carbide with, I believe it's a zirconium nitride coating, but it's designed specifically for aluminum and they work really well for me. So I'm going to jog over a little and set my Z0, set the tool tip to Z0 at the base, because I'm going to be cutting a profile on this part, and it's not super critical if I scar up the base because it's not, it really doesn't matter that much, but I don't need to go too deep and I don't want to go too deep. And so that's why I set the 0. Oh, let me deburr that tapped hole just a little bit. Even though I have a full 3-axis CNC, I find that for making one-off parts, the 2-axis is just so much faster. Okay, checking to just a little sanity check to make sure that the profile looks reasonable. Also looking over here where it actually matters to make sure that my tool diameter compensation is correct, that it actually, I did program it for a 3/8 carbide end mill. Now one of the things that I like about 2-axis milling, unlike 3-axis milling where once you push the start button, even if your finger is on the stop button, sometimes things can go wrong before you push the stop button. One thing that I like about doing these quick and dirty, where I'm not spending a lot of time thinking about it, that with the 2-axis CNC, I can have the Z safely far above the surface and then just kind of do a practice run, kind of do a dry run, and just as a kind of a sanity check. Does this look reasonable at all? And yes, it does, in fact, look reasonable. So stop, rewind, wrap it back to the start position, and when I'm doing production on the 3-axis, I actually take the time to optimize the cycle time, optimize the tool path, optimize feeds and speeds for maximum material removal. For these prototypes, I take it easy, I take it conservative, I take smaller cuts than the maximum and just try to not break tools and not get in trouble. Running at 4,200 RPM, which is pretty much as fast as the Bridgeport will go. And this is 10 inches per minute at a 1/4 inch depth of cut. And I'm looking very carefully for chip evacuation. The mist coolant provides fairly decent chip evacuation, but when I have had cutter problems, it's always because the chips get caught. So I got my air nozzle at hand, ready to go if I see tips piling up, but they're not. The cut is proceeding very nicely. All is well. Take it down to Z0. And it is putting a little mark on the base plate, but I don't care. Notice how quickly the cutter stopped rotating when I pushed the stop button. That's one of the really nice things about the VFD, that it has electronic braking built in, and so it stops the spindle really, really quickly without having to use the old school spindle brake. So I'm going to go check something. When doing these quick and dirty one-offs, sometimes I don't remember every detail and I get out of sequence, and I just remembered that this part needs 3 more holes in it. And a really convenient thing about the way my shop is set up, I could just, the machine shop is right next to my office, so I can just duck into the office, go to the CAD system, very quickly whip out a tool path, and be back in action. So let me get this tool path going. It actually would have been slightly more convenient if I had done this in sequence, but this is not a problem at all. So I'm going to be resetting my zero, my Z0 at the tool tip. Time to refill the coolant bottle. Okay, coolant refilled. There we go. I'm using the DRO to control the depth of cut. If I was in production and doing a lot of holes, I'd probably set the stop on the quill, but for this, and it doesn't have to be accurate to within a tenth. So there we have the part, and just so you understand what the function of this is, the wood will be bent around this surface. This is the surface that will determine the overall size, the shape of the bent wood, and then the glass piece gets mounted up here, and then there's a base down below it. So, in keeping with my theme of not remembering to do holes correctly, it turns out that the base also needs these holes. So and yes, I could have drilled all the way through when I had the other piece in place, but that's what happens when I'm trying to do a quick and dirty fixture, doing the minimum amount of planning necessary, trying to make a video, trying to remember what's going on, but and of course I could have power tapped those holes with the same setup if I would have remembered, but hey, if all I make is sequence mistakes, I still end up with a successful result. Okay, let's get those deburred a little bit. And I got a little bit of just make sure that my reference surface is flat here. Now I'm returning to the 3/8 3-flute milling cutter and going to reset my 0. When I'm doing my production work, everything is a lot more organized and under control, and I make a whole lot less mistakes but for the quick and dirty one-off prototypes, sometimes I get out of sequence. But like I said, sequence errors are not a problem. Checking to make sure the camera is still on. Yep. I've had problems doing my glassworking videos with camera shutting off. So I don't have a toolpath for that, so it's back to the office. Yeah, it's really convenient to be able to just go into the office real quick and just very, very quickly make a toolpath. Some people who probably either have more complex procedures or have never done CNC work would imagine that making a toolpath using a toolpath program is a kind of a hard thing to do. And well, that's why a lot of CNC machines have conversational programming, and a lot of old school machinists kind of are maybe a little bit scared of CNC, but once you get used to it, once you get it all set up, it is so fast to just make a toolpath. And once again, doing just a little bit of sanity checking, both looking at the preview screen, looking at the G-code, looking at the toolpath with the Z at a safe height, and I believe that I am safe and ready to go. Well, not that ready. Okay. Back up to 4,200 RPM. I'll be doing this in 2 passes, 10 inches per minute. About 3/16, it's a 3/8 piece, so it's about 3/16 per pass. I know the machine could easily do it in 1 pass, but I'm in no hurry. And like I said before, for prototypes like this, just being conservative is just fine. Using the DRO to go down to my preset Z0. I've got my tool rotating so that it's effectively doing climb milling on the finished surface. I find that this gives me an excellent surface finish for these quick and dirty prototypes when I don't need to have a really, really nice finish. If I do want the best possible finish, I'll do a separate finish pass, but for this kind of work, it produces produces a finish that's good enough. And there we are. The profile milling of these three pieces is now complete. And the way they're going to go together, it's going to be a kind of a stack up that the clamp is slightly larger in size than the actual surface, the bending surface. So the base goes first, the bending surface goes second, and then as the pattern is developed in the wood, the clamp will be clamped onto the top to hold the piece while it's in progress and while the milling is done on the outside surface. The wood fabrication is going to be rather complex and rather tricky, and hopefully, if everything goes right, it's going to come out really nice. So now the base plate is finished, and just going to drill a hole here in the end, drill and tap a hole here in the end for a piece of threaded rod, and the rod will actually provide the force. There's going to be a metal band that goes around the outside and squeezes the wood pieces together, and a piece of threaded rod coming out here with another aluminum part that pulls the band out and hopefully gets it all into shape. Of course, like everything in this project, it's a prototype, it's the first one ever, it's all experimental. I'm hopeful that it'll work really, really excellent, but hey, you never know. I'm kind of, this doesn't have to be accurate to machine shop tolerance. So I'm just eyeballing with a parallel in the edge of the vise, just eyeballing the surface to make sure that it's horizontal. I tend to use the amount of precision necessary to accomplish the work I'm doing. If it needs to be precise, I try to be as precise as my skill allows. If it doesn't need to be precise, then just do it as well as it needs to be. Okay, finding the right size collet for this tap drill. I typically have two sizes of tap drills for every tap, for aluminum and for materials where I really need the full strength. I'll use a 75% thread and a smaller tap drill. For steel, most steel, where I don't really care about full strength and I just want to be able to tap easily without the risk of tap breakage, I'll do a 60% thread, and for most things that I do, that's just fine. So I'm gonna just by hand here, after having talked about doing toolpath for all my drilling. Well, no, I don't do toolpath for all my drilling. Sometimes I just do it by hand. And I'm going to put in the G0, or I'll be here all day. And I don't remember what that dimension is, so back to the office for a quick refresher. Something that was a kind of a side effect of starting to do CNC machining. When I used to do all of my work manually, I kind of got not quite obsessed, but I thought when I was designing things, I thought about, you know, I like round numbers better. I like 1.25 better than 1.617. This dimension just happened to come out to 1.617. I don't know why, it just came out. But now that I'm on CNC, I just poke it in and move on. Okay. Oh. Back to the power tapping. So now the parts are complete, and time to get ready for the next operation. I have a couple of more little things that I need to make, but they're not that interesting and probably isn't worth getting out the camera and doing a video on them. Who knows, maybe I will, maybe I won't. But the wood construction is going to be very interesting. It's going to be the first time I've tried this particular thing. I've done a lot of laminated wood, a lot of bent wood, but never done exactly this design before. And it's got a couple of potentially troublesome spots that may require, the first one doesn't work, so go back to the drawing board. So anyway, servo's off. Thank you for watching.